Good morning students. Today we are going to discuss what is heat flux, what is the definition, units, and why heat flux term is used, why not just Q, why Q by A. These things we will discuss in detail. So what is heat flux? The definition of heat flux is the quantity of heat transferred per unit time, per unit area. So this is heat flux. Quantity Q. What is Q? If you see, no, Q is quantity of heat transferred. Quantity of heat transferred per time. That is Q. Usually we use, I am using the notation small letter according to McCabe and Smith. And in some other textbooks, capital letter, capital Q also is used. Here we are using Q for the rate of heat transfer. Quantity of heat transferred per time means per time. That is given, also known as rate of heat transfer. Okay. Quantity of heat transferred per time is called rate. Per time. Per time is always called rate. So rate of heat transfer. So its unit is what now? Unit is either watts. Watts is because joule per second, isn't it? So joules is heat energy unit. So quantity of heat energy transferred per unit time, joule per second, that is watts, or kilocalories per hour, or BTU per hour. These are the units we use for Q. Because this Q is the term in heat transfer, the most important term. We always try to calculate Q in heat transfer. In chemical industries, there are many applications, like what amount of heat is lost from a surface, like from furnace wall or from steam pipes, like that. That is why Q in heat transfer is the most important quantity we need to calculate. Our problems are always to calculate Q only. Okay, so first before starting the heat transfer subject, you need to know the how quantity of heat transferred per time is represented by Q. So it is a rate of heat transfer. Throughout the subject we use the same notation, Q only. Okay. So rate of heat transfer. So now rate of heat transfer per unit area is heat flux. So this definition is also can be written as rate of heat transfer, HT, heat transfer, rate of heat transfer per unit area. This is heat flux. Okay. So rate of heat transfer is what here? Q. Area is A. Therefore, heat flux we are representing by the term Q by A. Okay. Rate of heat transfer per unit area or quantity of heat transfer per unit time per unit area. Up to this is rate of heat transfer per unit area is Q by A, heat flux. So heat flux units are now what? Q units are watts. So A is meter square, okay? So watts per meter square, or Q is kilocalories per hour and area is meter square, or another unit in FPS system, it is BTU. BTU per hour is rate of heat transfer Q per meter square, that is feet square. Okay, these are the units for heat flux. So now you understood the term rate of heat transfer, two terms, rate of heat transfer and heat flux. Q is the rate of heat transfer, means quantity of heat transfer per unit time. Okay. So quantity of heat transfer per unit per area, if you take that term is called heat flux Q by A. Then you may get doubt, why not just Q, why this term is important Q by A. Okay, why heat flux term is important? Is it Q is not sufficient? Why is necessary to calculate the final calculation in terms of Q by A? That point also we will discuss. Why heat flux? Okay. We'll discuss why means importance. Importance of the term. Importance of the term Q by A. Okay. For that, you just consider in chemical industries a furnace wall. Consider a furnace wall. So this is the importance of heat transfer here. It's a furnace wall. Let its thickness be B. Okay. Then its inside temperature is maintained at T1 because for furnace inside temperature will be very high. So that is T1 and outside temperature will be near to ambient temperature because outside temperature can't be so high. We need to work out outside. So it should be near to the ambient temperature. So this is T1 here and this is T2. Let the thermal conductivity average thermal conductivity of this wall is furnace wall. Then the engineers calculate the term Q. Calculate the term Q. How much heat is transferring from inner surface to the outer surface? Okay, they calculate Q and then they tell this much quantity of heat will be transferred or will be lost here. In case of furnace wall, it is loss only. Whatever the amount of heat that is going outside, that will be loss only. So, what will be the transfer loss of heat? That they give in terms of Q. But you just think in some industries, the area of the wall may be 100 feet square. Okay. Because area is also important in calculating the total rate of heat transfer, isn't it? So, in some industries maybe 100 feet square or in some industries maybe 500 feet square, etc. So, the area may be different. So, what will be convenient now if the engineer gives the calculation for Q by A, that is Q by A, that is per meter square, then for any area of the wall, if it is for if A is 100 feet square, then what we say, Q is equal to Q by A into A. That is if it is this is X here, X BTU per hour per feet square. Okay. So this is now X into 100. You will have BTU per hour. Okay, like that. For any area, you can calculate the amount of the total amount of heat transferred per unit time. You can calculate by multiplying with the area. If the area is 500, we write 500 like that. So it is convenient to use the term and represent finally after solving the problem. It is convenient to have Q by A. That is the importance of this term. In the same way here, see steam pipe, if you consider heat loss takes place from steam pipe. What is the amount of heat lost from this steam pipe means we calculate Q. But it is convenient to represent by Q by L per unit length how much it is. Then whatever, if the length of the pipe is 100 meters square, then into 100 you will have a Q. In some industries they may be using some 500 meters like that. So or Q by A, whatever it is. So per meter or per area, it is convenient term depending upon the application. Therefore, heat flux is a very important term. For example, I tell you one example. Suppose if you go shopping to purchase some shirting cloth, okay, then what the shopkeeper tells you about the cost, he'll show you the different varieties and he'll tell you the cost per meter, isn't it? You may take 2 meters or you may take 5 meters. That is afterwards. But the shopkeeper tells you the cost per meter, he tells. If you take 5 meters, suppose per meter 100 rupees means, then if you take 5 meters, 5 into 100, 500 rupees you will pay. So in the same way, engineer in chemical industries also calculate per meter square what is the amount of heat that will transfer through a particular furnace wall or from a steam pipe or whatever it is. Then depending on the area, we can calculate finally the total heat transfer. That is why Q by A term is very important in heat transfer. We always represent heat loss or heat gained in terms of heat flux. Okay, thank you.